nitrogen pentoxide, nitrogen trioxides, isn't it? They will form acidic nature. Similarly, phosphorus oxides are also what? Acidic nature. Next, what about the arsenic? As2O5, As2O3, they will have weak acidic character. Next, if you observe the antimony, antimony will form amphoteric oxides. Isn't they neither acidic nature nor basic nature? They're what actually amphoteric in nature. That means they react with what? Acid. They react with what? Base. Both it can react. Whereas acidic oxide, isn't it? Definitely, they always will give acidic solution in the water. Whereas the basic oxide, they will give basic solution in the water. As amphoteric oxide, they reacts with acid and bases. Therefore, they are called what? Amphoteric nature. And finally, we'll take the bismuth. Bismuth is forming what? B2O5 and Bi2O3. They are having actually basic nature because bismuth is a metal. So, metal oxides are generally what happen? Basic in nature. Here, important thing is that Bi2O5. This is very, very important here. Does it exist? Ba2O5. Already in the last class, isn't it? Because of the inert pair effect. Because of the inert pair effect, isn't it? We have already discussed about that. Bismuth can exhibit what type of oxidation state? +3 and +5 generally, but this is not present. This is absent because NH2 electrons never participate in the bonding. If NH2 is not participating, only the 3 electrons will involve in the chemical reactions. So we are going to get the bismuth +3. So here you observe here +3 oxygen state Bi2O3 exists. +5 oxygen state Bi2O5 do not exist. Remember why Ba2O5 is unstable, exists but unstable. What I mean to say is unstable. Why unstable? Because of inert pair effect. If a question arises in the exam, why Ba2O5 is less stable, explain. You can explain by just simply by saying what? Inert pair effect. Next, some things are there which are very important. When you observe the oxides of nitrogen, especially only I'm saying nitrogens here, like N2O5, NO2, NO3. See, I'm writing something like N, isn't it? We'll take what? Double bond O. This is a dative bond. One is dative bond, other is double bond. Now here, this is the pi bond actually. Now this pi bond is formed between the p pi orbital of nitrogen, p pi orbital of oxygen. Now which type of pi bond is? P pi bond here. But in the case of phosphorus, this type of p pi do not exist. Why? Because p pi size is what? More. Because of small size of nitrogen, it can form p pi bondings, isn't it? Whereas in the phosphorus, they are not possible because large size of the phosphorus. So what is possibility? D pi p pi. For example, I'm writing the, isn't it? What we are having something what? P4, P2O3. If I write something, you can take any example of something like P double bond O. Now from this D pi orbital, from this what? P pi orbital. So between these two, what happened? Bonding is taking place. So what I mean to say, nitrogen, P pi, phosphorus, D pi, P pi. Finally, when you take E2O3 and E2O5, in which case, +3 oxidation state and +5 oxidation state, if you observe, +3 will be less acidic when you compare with +5. So this will have more acidic. For example, you take N2O3 and N2O5. Between these two, N2O5 is more acidic nature when compared with N2O3. Similarly for P4O10, P4O6 also. Why? Because when you have what happened, lower oxidation state, it can release more number of. See, the case of what? +3 ion, +3 oxidation state, this will release less number of H plus ions in the water. In the case of +5 oxidation state of nitrogen, it can release more number of H plus ions in the water. So that is the reason what happened. E2O3 is less acidic than the E2O5. And finally, very important thing is that Bi2O5. This is highly unstable because the oxidation state of bismuth is here +5. See, already we discussed according to inert pair effect, NH2 electrons never participate in the bonding. So bismuth is having inert pair effect. So it never exhibits generally +5 oxidation state. So that is the reason what happened. Bismuth +5 do not exist. Therefore, this is highly unstable. Whereas the Bi2O3 is what? More stable because of absence of inert pair effect. +3 is what? More stable oxidation state. So we can also say here Bi2O5 can convert into Bi2O3 by using what happened? Reduction. Therefore, it's a very good oxidizing agent also we can take here. So this is about the oxides of what? Group 15. In the next class, we are going to see halides of the group 15. Thank you very much.